Yes, sir.
All right, very good. Give me one more second for setting up everything. All right. One more second, because I want to be able to see the faces of anybody who chooses to take off their video, plus be able to see the participants and the chat window. Okay, so because I'm presenting and looking at 10 things at once, I'm probably not going to be able to respond to questions in chat, but feel free to put them in there. Also, you can unmute yourself and stop me at any point and ask questions. The one thing that I really miss about doing this, I did 52 sessions in 19 at VMUGs. So the thing I miss the most about doing these is the interaction. So don't hesitate to stop me and ask questions as we go along. I'll introduce some natural pausing and just my cadence of conversation so you feel like you can kind of say, hey, Joseph, before we go to the next slide, question kind of thing or whatever. So don't hesitate to unmute and ask me questions as we're talking. I don't think most of you have met me before, but I'm a business solutions strategist at VMware. There's my Twitter handle, and I'm a VMware certified design expert, as Ben mentioned at the beginning. So let's take a quick second to practice virtual interaction skills. So I'd like each of you to locate the reactions tab on your Zoom session for me, those of you who are not asleep right now and those of you who are not solving critical issues, which means that like me and Ben are going to respond here. But the rest of us, if you could find it for me, if you showed up to listen to Wade, give me a thumbs up. Yeah, there they are. There's the thumbs. I got to go to gallery view to see them all. Go. Thank you. If you showed up to listen to Chirag and Selva, give me a thumbs up too.
Yeah.
There we go. Yeah, that's good. I've known Chirag for a long time. He's really great. So you're in a good category watching his. All right. If you showed up to listen to me, give me a crying face.
I'll do crying face, but I can't find the emojis.
All right. Yeah, if you can't find the reactions tab, don't do anything. That's the last part of this quiz. So I could show you, but then I'd have to go out of full screen mode, and that might just mess up the whole world. So thank you for the interaction. I appreciate it. That's exactly what I was asking for. So look, throughout this, there's going to be a couple different times I'm going to ask for you to interact in various ways, and that's mostly because it makes it a lot more fun. Like I said, don't hesitate to unmute and comment like we just got. That's great. When we're talking about this topic of operational debt, it's a really interesting problem because almost every my core job at VMware is to talk to executives, and almost every conversation is laden with the word technical debt. But often we don't actually have a conversation about the operational portion of that. And so, I'm going to be talking a little bit about that. And but first, we're going to start out with something a little bit funny. So, how do you tell how long a person's been in IT? We got 3 different people here with different times. I'm at just north of 15 years. Chirag is at 20, and Wade there was at 25 based on his introduction. The number one way that you can tell whether somebody's been in IT is based on the status of their beard, because it's all about the V beards at the end of the day, right? Mine is just getting started. Chirag's got a pretty nice one there, and Wade, he's growing some serious business on his chin. So, you can tell Ben's been in the business for a while because he's got some beard business going on there. See, yep, that's a 20-year plus at least action going on there. I can tell on the chin. So exactly. Now, if you go to VMworld, you'll be able to run into the V beards guys, and there's some guys there who've got beards that go down to their toes. Yeah, that means you've been in since the mainframe days. So just keep that in mind, that I'm at the 15-year mark with mine, and I haven't got the right to grow a 20-year beard yet like Ben, but that's where we're at today. So let's see if you were listening to the introduction. Let's use the chat panel for this. What percentage of IT budget is spent on operational cost? Give me an A, B, or C in the chat panel as you vote, and there will be prizes. So, better pay attention for about 10 seconds here. Oh, B, there we go. Okay. Thank you for voting. I appreciate you interacting with me. Great. It looks like most people said C, or 70%. For those who said C, you got the correct answer, and I'm going to give you your virtual prize. a can of corn. Enjoy virtual corn. That's about as good as I can get because I can't ship anything anymore, and I usually bring prizes for people who get it right. But you're absolutely right that based upon Gartner metrics from 4 years ago, 70% of IT budget was spent on operational cost. So 7 cents or 70 cents on every dollar.
Couldn't even make it a piece like a virtual steak?
You know, I didn't even think of it. I'm actually known for corn, so I generally carry a can of corn to VMUGs with me and show it off, so that's just my moniker. But you're right. I should have made it a virtual steak or, I don't know, a virtual Lamborghini or something, right? As long as I'm giving away virtual prizes, right? Everybody gets a virtual car. Enjoy. So good point. Next time I'm going to put a virtual car there, Ben. All right, so let's start out with the conversation of debt. I think this is a fairly simple example that pretty much most of the rooms probably dealt with at some point. Let's assume that you're a human being and that you make $50,000 a year. You may make less, you may make more, but for the sake of my analogy, this is what you make. And you decide you want to buy a house. That house costs $180,000. There's a principal amount, there's an interest amount, there's a term for the loan, and there's a total interest that you're going to pay, and then there's a monthly payment. And you know, the funniest thing about all of this is there's only one thing that you actually care about in this, the monthly payment. Because you got to figure out if the amount of money you make can pay off this thing. You know, if you're getting up there in years, you might care about the term. You know, when I got my last home loan, I realized that I'd be 72 years old before I pay it off. So I'm a little concerned about the term of my loan right now. But most of the time, you're actually only concerned about the monthly payment. And that's what's interesting here is that when you think about operational debt or debt as a whole in IT perspective, they're worried about the initial cost, $180,000. They're actually most of the time ignoring the total interest they have to pay, which equals half of the original cost to get into the thing. And they're also ignoring the monthly payment, which is what most of us are doing in operational debt. We're making that monthly payment. Now, for IT, this is a little bit more complex. Allow me to illustrate it. It's more like this, right? You make $50,000 a year, and we have a whole bunch of mansions. I just picked these off Zillow, so forget the pricing. I just went for expensive, anything between $1 and $2 million houses. And in New Jersey, I'm sure that you're not going to get stuff like this for $2 million. It's probably a lot smaller, honestly, just because of real estate prices, depending on where in New Jersey you are. But the interesting problem here is that this isn't really an accurate representation because these are beautiful, well-kept up, super expensive houses. The accurate representation is it's more like they keep bringing on new projects and new initiatives because the amount of IT is not decreasing. The amount of things that are becoming digitized is only increasing. So they're actually adding, well, you got twice as many as you had last year of beautiful houses. And while we're talking about this, let's not forget one of my favorite parts of IT, right? The broken down legacy systems that exist. Yep, remember those? Either your mainframe or your Windows 2003 systems or something else. These are the broken down jalopies that you have to maintain that actually take 99% of your time. Because I'll tell you, I bought a new house a couple of years ago, and I didn't have to repair anything. The house I owned before it was 25 years old, and I spent every Saturday on a ladder working on that place. There's a big difference in the amount of money we have to spend or the amount of time we have to spend repairing these broken down legacy systems compared to these net new houses. And worst of all, if you think about this, there's no way that one person with 50,000 a year is going to be able to pay for these places. And you really can't define the interest rate or the term of the loan. I guarantee when they built this particular IT system, they didn't think it would still be around today. They didn't plan for that eventuality. Guess what? It still is. And that's the biggest problem with this example of debt is that we're not planning for systems' length of time or the interest associated with it. So what is one of the simple ways to solve this? Yeah, throw more people at it, right? That's a simple way. That works, right? Just get more people. The more people make more income, can produce more reduction of technical debt, and we can solve this issue. Well, the problem is that, frankly speaking, IT budgets aren't going up. We're not able to get, already spending 70% on operational costs, whether it be software costs or whether it be people costs. So the reality of it is we're really stuck with this. So what do we come down to? Debt is bad, right? Debt is horrible. It'll kill us. So if you think about it, we need some examples of how to overcome this operational problem of maintaining these broken down houses, because not every house is going to be in perfect condition. And frankly, we don't have the staffing to be able to do it further. So overcoming operational debt is best illustrated with a story. One of the best stories I can possibly think of is the Google SRE story. And I know Chirag's going to be talking about SRE later, so that's really a good lead in. It's nice how we talked about how we find out there's problems. I'm going to be talking about how we solve them, and then he's going to be giving you some specific tools and capabilities to do it. But one of the stories that I love is the Google SRE story. So for those that are not familiar, the story goes something like this. Google had gone out and engineered a way for them to be completely built in microservices for search. And it was working pretty well. They were able to globally scale. They were able to go up and down in auto scale capabilities, and search was working pretty well. But they were having one area of problem, the operational side. Things would break, and you'd have to pull people in to do it. And they projected that at the way that they were growing, in other words, throwing more people at this problem, that search would become no longer profitable within 3 years if they didn't fundamentally change the way that they're dealing with operational debt. Because operating this global, scalable capability was extremely expensive from an operational standpoint. So Google made a pretty strong decision that they would dedicate a team to this problem. And the team that was dedicated decided that they were going to solve it in one way. They would take 50% of their time in the morning solving tickets that came in related to search and operational problems. They would spend 50% of their time in the afternoon automating the things that they fixed manually in the morning. And the team would flip-flop. So the one half would be automating in the morning, and then the other half would be automating in the afternoon. And this was their process to reducing operational debt, was really how do we get to the point where we can afford the monthly payments of all the complexity of IT systems with less people. And so today, search has an operational team of 1,500 people and an average revenue of billions that it runs through it. And by billions, I mean like, $80 billion that run through it. That's pretty amazing if you think about that operational ratio to the revenue that they're producing. And all that was possible because they made an investment in solving their operational debt by beginning to automate it away one step at a time. Now, the interesting thing about this whole process is, we really needed to define what is the impact of operational debt. Because in order to convince people to do these kind of things, you've got to have some way to say, this is why it's a problem. Every customer I talk to, every company I talk to, every CIO I talk to, talks about the need to have greater agility. Personally, that word means nothing to me, frankly, right? But when I think about it, what it really means is that they don't want their teams tied up in doing something that doesn't drive business value. And as sad as it seems, fixing the things that are broken doesn't drive business value. It actually interrupts business. And they have scalability challenges. So when I define agility, it's really about the ability to have things operate on their own so you have free cycles to go fix problems and to go solve the real business challenges. In other words, if the business comes to you and says, hey, we need to deploy a new application in 2 days, the response shouldn't be, well, we've got too many broken things on the old app. We can't do that. But that's the response today by a lot of operational IT departments because, frankly, they are buried under the operational debt. So let's take a look at this from a financial perspective. And this is a very simple graph. Your graph is going to be more complex. But let's take a look at this in the idea. So there's a couple assumptions that come out of this. The assumption is that your current spending on operations is $500,000. I'm willing to bet most of the companies that you work for actually spend more than that on people operations. But let's assume it's $500,000. And let's assume that there is a 5% growth in your IT environment year over year. And we're going to make an investment of automating 10% of the operations year over year. So the blue line represents the 5% growth and the increasing cost over 5 years at a 5% growth. And the blue line, or the green line, represents the 10% automation and that divergence with the growth. If you can think about it, it looks a lot like compounding interest. You're going to reduce over time, and your value continues to grow. And what happens if you don't grow by 5%, but you grow by 10 or 15%? The same scalable automation benefits you, because once you automate something, you never have to automate it again. Allow me to give you a simple story from my own experience on this. So a couple years ago, when I was working as an enterprise architect and as an automation expert for a customer, I was involved with a group that handled multi-tenant server operations for a large entity. And one of the things that we did was we thin provisioned storage on the VMTK, and we also thin provisioned on the backend storage array. Now, this created an interesting challenge, because at the end of the day, if the backend array ran out of space because the LUN hadn't been expanded, but we expand on the VMDK side, we would have the VMs freeze, and it would cause a service interruption for our customers. That's a pretty big problem. And so because of that, we had someone in operations who would run a report 3 times a day. And it would look at the current size of the LUN and how close we are to being full. And then they would manually open a ticket in ServiceNow for the storage team to expand that LUN to accommodate the new sizing. And this had to be done 3 times a day. It took roughly an hour to an hour and a half of someone's time, 3 times a day. And we even had to get someone who was on call to do it 3 times all weekend long to avoid this problem, and then do an emergency ticket to the storage team to expand their LUN. This is a perfect example of something that could be automated, and it's simple. So we started out simple, PowerShell scripts, just to notify us, run every hour, and tell us when a LUN's getting close, and tell us the amounts that we need to enter into a ticket. And then we started to get a little bit more wise, and we realized that we had vRealize automation hooks into ServiceNow. And so we could do everything on our side: observe the LUN, open a ticket with the right information, watch the ticket. As soon as the ticket was closed, expand the VMFS volume inside of VMware and close the change ticket saying that we did that work. And no human from the IT team needed to be involved. Now, the storage team was still involved because they were still manually expanding the LUN. But we were able to take an hour and a half a day out of someone's time and gain that as time that they could spend automating things. And that person spent an hour and a half finding additional things to automate. And that's where the benefit from automating our operations really starts to come in, is that every time we save the big hitter problems like this, we can then automate it. My favorite moment of this story is when the CTO came down and he said, "Hey, I just heard about how much time that your team saved us by doing this automation." He said, "That was really good work." And that was the first time I had ever spoken to the CTO, except during an outage. He would come down and tell us how soon you're going to get it back, so I can report it to the business. Instead, he was telling us what a great job we did. And we fundamentally changed the perspective of IT because of that. So with that story told, any questions at this point before I get into some of the common fixes I see out there that people are doing to solve the operations and automation? Give me a sad, cry face, just to make me feel better. I might have put the whole room to sleep. There we go. Thank you, Rose. I appreciate it. There we go. Now I'm feeling better. I just want to make sure I wasn't on mute with myself here. Thank you both for helping with that. I'm awake. There we go, Patricia. Thank you. All right. That's the part that I hate, is the non-interaction. So let's talk about a couple of the common ways that I'm seeing executives try to solve this problem. One of the first things that I'm seeing is managed service, right? And that's been around for 20 years. And that's just a fundamental shifting to a lower cost model of operations. It actually doesn't help you, and it doesn't solve the problem, because you're just shifting it to someone who costs less money and has less embedded reasoning to solving it. While there are models for managed service that make sense, it's not solving the problem. But beyond the managed service play, which has been around forever, one of the big ones we're seeing right now is public cloud. Gives you faster infrastructure as a service and some cool capabilities. It immediately removes hardware debt and software abstraction debt, so things like upgrading your vSphere. And it definitely adds some unique services, but it creates new realms for debt. Like, automation of power off policies. It's one of the most common things I see in public clouds is that, you're going to save a lot of money if you remember to power off systems. So now we get into very complex power off policies, which are all operational dead things. And if those things don't work or something's left on, guess who gets the blame? Not the IT department that's not doing it. It also ignores the long-term state of the application because it's primarily an infrastructure as a service play. The one thing that we do learn from public cloud adoption is that there's a huge value in software abstraction of infrastructure because that allows us to automate it. In my story that I told before, the reason the storage team couldn't automate expanding the LUN was because there was no API interface into their storage array. So they had to do it manually through a web interface. They couldn't do it any other way. Wade, you got a question?
No, I was actually just trying to get rid of my reactions menu. It was stuck open. I'm sorry.
I'm okay with that. Just wanted to make sure I had an opportunity to catch you if you had a question. So public cloud does actually teach us that software abstraction is great, and it's not a bad thing. It's just not going to solve operational debt. So automation of provisioning is the number 2 thing I see. Everybody is going out there and trying to solve how fast can we get to the initial state. Everyone is building some sort of automation system to be able to get to that initial state. And the funny thing is, we're only making operational problems worse. Think about the Google story. They solved initial state. They even solved desired state because they were using containers. And what did they end up with? A huge operational nightmare. Provisioning itself doesn't solve it. Now, the great thing about provisioning is that it standardizes the initial state, which makes it easier for us to automate the operational state. If everyone provisions a server a different way by clicking different things, it's extremely hard to automate. So provisioning and automation of provisioning is actually very valuable in the journey, and it's not a bad place to work. But if you ignore the operational day 2 stuff, you're ignoring the fact that that server or that system will exist for 10 years in a non-ideal, non-automated state. So, it really, at the end of the day, self-service expedites the compounding debt. So if you move beyond that and you talk about the next trend that we're seeing, which is microservices and containers. Too many companies are looking at microservices and containers as the catch-all to solve all your problems. And most of this is because they're moving toward the idea that immutability will remove all debt. Quite simply, it's a lie. Declarative state and immutability do have individual benefits. Like the idea of not having to repair something, just replace it with the same initial setup is extremely valuable, and it is a powerful capability. But the problem with microservices and containers is they introduce extreme new levels of complexity. I had a great conversation with a New Jersey native yesterday who works for VMware, and he was talking about how an average microservice system that used to be 2 or 3 servers is 200 or 300 containers now. When you really get to the microservices 12-factor world, you're talking about managing 200 or 300 different resources that have an average life of 10 to 12 minutes instead of 10 years. So now we have a scale problem that creates acute operational debt, because when you're trying to figure out where the problem exists across 200 containers, you've got some real challenges without proper observability. So declarative models are the one thing that we do take away from this particular trend, which is they allow us to better enforce initial state and desired state post-deployment. So if you know that this should be built with this code and built in this way with these firewalls, you can always go back to that and say, not the way that we expect it to be, fix it to that. So that desired state management is actually very interesting. It's where configuration management was supposed to be, and the ability to repave it when it deviates from it, in other words, redeploy it, is a very powerful capability instead of spending a lot of time repairing, because that can be part of your operations. All right. So at the end of the day, I said that I was here to help you figure out how to address operational debt, not just talk about all the problems of it. And so, from this, I want to give you a idea and a way to look at this problem from a business perspective, and then I'm going to give you 5 operational steps that will help you, things that any of you can implement in your environment, because a lot of these are interesting, lofty ideas that executive management may be talking about, or that you probably should be talking about with your executive management. But at the same time, you need some steps that will help you get to where you want to be. So the first thing is to talk about the way to look at this. There's an idea going around right now of project versus product. And I wanted to use the house example to explain this. So the way that most of the funding and most of the capabilities come in now is a project, right? And to me, that's exactly what we have with this one house, right? We have a cost that we've associated with it for principal. We know that there's going to be some break fix that we're going to associate with it. We know it's going to last for maybe this long, and we get an idea. And the way we look at projects is we allocate resources at first to get the project done, and then afterwards, the operational overhead of this project exists on the hands of the teams that already exist. We don't dedicate teams to keep this running. It's just a project. It lasts for 9 months. It's been released to the wild, and after that, someone just has to keep running it. I'm willing to bet that most applications in your environment are handled in this way, that they're a project, and then after they've released it, they're good to go, and then they come in with a new project to update it or fix it or add features to it, and they allocate money, one-time money, instead of allocating money over time to pay down the principal and to pay off the interest. Now, the interesting thing about the operational cost is in the project methodology, the business is always going to ask, why is this so expensive? Why is IT so expensive? Why do I need a developer? Why is it costing me so much when it's so simple? Because they don't look at it as an ongoing product that they're offering to the customers. They look at it as a one-time expense. Now, anyone who's bought a house knows there's no such thing as a one-time expense. Even after you pay off the house, you still have to pay taxes. You still have to repair it. You still have to work on it. There is a product association with this that it's going to exist as long as you do. So if you look at it from a different perspective, as a product, look at it instead of the monthly payment. Look at it from the monthly revenue. Suddenly it becomes a lot easier to justify maybe a dedicated developer, a dedicated operations person who's focused on making this continue to return the value that it provides to your company time over time. And that's a really interesting difference if you start to think about it. How do we, instead of look at this as a one-time project, we look at it as a product that produces something valuable for the company? We'll assume that the MBAs that thought up of this idea at one point had some sort of value proposition associated with it that was in revenue terms, not in this is how much it'll cost the company, right? You need to associate to that revenue and start to attach the fact that in order to maintain that revenue, in order to maintain that benefit, you need to dedicate people to it instead of we have a department to handle that. Now, of course, it's a department to handle that, but you start to get these products instead of the projects to fund long-term operational sustainability, and you can change the conversation at your company. Okay, so there's an idea for you to think about and how you do it. You can do a bunch of research in project versus product. There's millions of articles, and most of it's talking about development, but the same reality exists for IT operational debt, in that if they're going to fund a dedicated developer, why are they not funding a dedicated operations person? Because I'm willing to bet the developer does less work than the operations person to keep this thing running post-deployment, post-code changes. All right, so let's talk about the 5 steps. The first step in automating your operational debt is to get as much software-defined abstraction as you can. Why is this important? Because you can't automate things that can't be automatable. If your process to achieve the outcome that you're trying to achieve requires that you physically go and do something as a human, it can't be automated. So as much as possible, you have to move to software-defined abstraction. It's the number one most attractive thing about public clouds to people, is that everything is software-defined, abstractable, and able to be provisioned on demand. When it requires a human to do the work, it moves that away and you lose it. If you have a storage array that doesn't have an API, it's time to consider a different storage array in your next refresh. Make that a requirement. Start driving that into your environment as a requirement, saying, look, we can be a lot more efficient if we have this API. I remember working for an organization, and that was the number one question we would ask on any RFP for anything. Do you have an API, and what functions can be done in the API and what functions cannot? because you'll find very quickly between those that are used to being automated and those that don't want you to automate. And you're going to quickly find those that have figured out how to really make interactions happen in a positive way. So once you have various things abstracted, I'm assuming all of you at least run vSphere or some portion of the VMware suite since you're at a VMUG right now. At the least, you have compute abstracted. That's really VMware's value proposition. I heard NSX mentioned, so for those people, you have networking and security abstracted. You may have storage abstracted. And really, it's all about getting you to the point where you can provision on demand resources without having to deal with physical constructs, because those slow you down. The next step is to identify toil. So this is really interesting. When you start to automate, the initial thought process is, I will automate the thing that is the most annoying thing to me. That is a mistake. Because generally the thing that is the most annoying thing to you is because it requires an immense amount of human judgment. It's something where you have to look at it, think about it, collate a bunch of information together and make a decision and then take an action. And that human judgment is one of the key reasons why you have a job. So automating things that require a lot of human judgment require you to codify every step in that judgment, and it's extremely hard. The other thing is you don't want to repeat, or you don't want to automate anything that isn't repeatable. If you do it once a year, don't automate it. If you do it 3 times a day and it takes an hour and a half, it's a good candidate for automation. It's just simple if you think about it, but it's a place where almost everybody fails is they go after automating something that is really hard and has a lot of different business rules. The other thing that should be considered in automation is things that are interrupt driven. And by that, I mean things that notify you and interrupt your flow of business. So let's take the Runecast example. You get an alarm from Runecast related to something in your environment. That's an interrupt. Now you've got to go take an action. If you can codify the action you take every time you get that interrupt, like a storage array full space scenario, or some sort of other common problem you run into, then it's interrupt driven, which allows you to take the feedback from something like Runecast or vRealize Operations or vRealize Log Insight or whatever. It allows you to take that feedback and action on it. It has to be something that you can have some sort of way where you can action on the interrupt that's coming. Now, can you create the interrupts? Of course. I talked about in the storage array example how we created a PowerShell script that would just check the LUNs and say, 90% full, time to do something. Here's the LUN information. That's an interrupt we created. Could have done in VROPS and other places as well. So identifying toil requires that you consider if it's repeatable, whether it requires no human judgment, or at least the human judgment can be codified as simple and it's interrupt driven. Now, go figure those things out. And one of the things you want to do is you want to think about how much time you spend doing it, because you can quantify the value of the automation you're doing based upon how much time you're spent doing it and an average FTE cost for your company, right? Let's assume that the average hourly rate at your company is $50 an hour and you spend 5,000 hours a year doing this. Simple mathematics to show the value of this particular automation, right? I don't know what your pay rate is. I'm just guessing numbers here, right? That's an internal conversation. So what do you do after you've done that and made the justification? You automate the toil. That's what you're looking for, right? Just go out and create automation. I don't care if it's PowerShell scripts, whether you use vRealize Automation, whether you use ServiceNow or what you use. You take the interrupt, you figure out a way to codify the human judgment, and you take the action. And the great thing about this is it becomes the perfect employee. Maybe your environment has a bunch of ITIL stuff, and you need to open a change ticket every time you do something. Great. Have the automation do it. Have it close the change ticket. Have it handle every aspect of that so that it's the perfect employee and you never have to deal with it. It's an absolute perfect way to solve all of these extremely lengthy and painful processes they do for auditability perspective in one place. And every time that you automate something that is repeatable, you never have to do it again. So if you double in size, triple in size, quadruple in size, that automation is beneficial. Also, if you move to public cloud, good chance that a lot of that automation will work the same, or that same automation will apply there. And so this is a value add that IT departments can bring to the table that will scale Whether you're in private cloud, public cloud, or a mixture of both, you can do these things. Now, we have to change some of the code. Yeah, there's probably a trigger here that says if this is GCP, do this API call instead of this one. But that's not hard to codify. It's not hard to put in here. So that's number 3. Go ahead and automate your toil. Number 4 is related to one of the ways that we can help solve this going forward, because everything we've been talking about so far addresses that broken down house in your environment, right? That big hairy problem that creates problems for you. There's at least 2 or 3 of those applications that you spend 90% of your time on while you've got a bunch of new houses that don't kill you. The 4th thing you can do is start to move your applications toward declarative models. And as talked about during the microservices and containers, the idea of a declarative model is, for me, is really simple. I was at Morimoto's in the MGM Grand in Las Vegas a couple years ago. And those of you that are Iron Chef fans will recognize that name because he was an Iron Chef for many years. And at the restaurant, the waiter comes out and he gave me an option. He said, you can order something off the menu, or you can tell me what you would like, and I will pick something off the menu that will be perfect for your needs. And to me, that's the perfect difference between declarative models. Is I said to him, I'd like something that shows off the talent of the chef and gives me an opportunity to taste different kind of flavors. And he said, okay, I'll get that for you. I told him what my needs are. What he provided, I don't care. It provided for my needs. It ended up being this dish that you see right here, which was a Thai curry seafood dish. It was absolutely incredible, and I never would have picked it off the menu myself. And that's the reality of the declarative model when you're working with your customers, is they should tell you what they need. Here are my requirements. How they get it, whether it's this cloud, that cloud, whether it's this storage array, that storage array, or this networking location, or this cluster, or that cluster, they shouldn't care, because they tell you what they need, right? And you provide the outcome that they're looking for to them. And if you move to that, the other thing is you can continue to hold that state true. If they say, hey, this should only be able to talk to this, you can enforce fire rules based on it and audit against that. And if it changes, then you can say, well, it's changed from that state, and we're going to deviate it back unless you tell us that it's changed and you want to change that. And that changed the declarative model. So declarative models give us the capability to ensure standardization and then automate based on standardization. You can automate a lot of activities away in traditional environments, but until you move to declarative provisioning models, it's going to be extremely hard to automate everything. But either way, the 5th step is to continue to remove toil from your environment. That's the way that you're going to continue to gain on operational debt and see that line go down over time instead of continue to go up. Because the number one complaint that executives have is that my cost keeps going up. They're completely ignoring the fact that the capabilities they need to provide continue to go up as well. But if you can find a way for the cost to be equal and the capabilities to be increasing through automation, you'll free yourself from a lot of pain in life. So here's our roadmap, and I'll be happy to share this deck with Ben, by the way. So if you want to post a PDF version of it, I'm happy to give it to you, Ben, for anyone who wants it. But if you want a screenshot, those are the steps that we found to be extremely successful in organizations that are looking to remove operational debt. Move to software-defined abstraction, identify toil, automate it, move to declarative for applications that make sense. There's always going to be the broken down house, and continue to remove toil in your environment. And the investment of time in removing operational debt will always pay back in the form of agility. Because when they come to you and say, can you do this? You'll say, sure, we've got resources to do that, because we don't have to do all this operational stuff that's been weighing us down. And with that, I'll take questions and anything else, comments, frustrations, whatever. Let's go.
Anyone have any questions for Joseph? Feel free to unmute yourselves or type anything in the chat. That was great, Joseph. Thanks for sharing.
I hope it was helpful. It's a little bit higher level than you normally would get at a VMUG. Normally there's a technology conversation here, But
Yeah.
I will tell you that this is a frustration that I continue to see. And this is an opportunity for the people in this room to bring this to their leadership as a way to solve a big, big problem that they have. It does matter. I talk about this conversation with CIOs constantly, and the biggest problem that they run into is they just don't know where to get started in solving it. So they start doing things like public cloud and things like, hiring managed service providers because they think that's the only tool they have. And there's a much better tool, which is automation.
Yeah, definitely. I know that that's something that if I have to do something more than 2 times, I'm trying to find a way to automate it. That's just one, it makes it easier to do the 3rd or the 4th or the 5th time. And 2, it's something that I can hand off to somebody else that might not know how to do that. Now all they have to do is run it.
At LabCorp, we're starting a big effort in automation, and finding the big roadblock is politics, getting around the, who's everybody's little silo and how they want to control things.
Yeah, that was one of the major problems in that storage story was not just the fact that they had an API, it was the fact that it was a completely different team and they didn't want our automation tool reaching into their world. But I'll tell you the funniest thing that came out of it is that after 6 months of us automatically opening tickets on a regular basis for them at a much faster rate than we were with the human side, they started having discussions with us about how we could automate it because we had moved the downward pressure off us into a different team. When you remove yourself from the bottleneck, a new bottleneck is created, and those siloed teams, they start to become the teams that are blocking.
We have a huge Splunk environment, and we created storage reports because they like to eat up, 14, 15 terabytes on each indexer. So that is one of the tricks. We're just doing a report. They're not letting us, create the automatic tickets yet.
The political side of this conversation is complex. And it's one of the reasons for software abstraction is the more that we can move to an abstraction, the more it seems like virtual bits and bytes instead of physical things, because people love, to hug their physical things.
I agree. Thank you.
It's not an easy process when the politics are not in your favor. Because you always feel like you're pushing a ball uphill. And that's why finding the things that you own and that you can automate that are your toil at least pushes the bottleneck elsewhere. And that's always been my recommendation is continue to push the bottleneck elsewhere and then count the amount of time that you're saving with the automation you're doing and drive that as an operational efficiency of time that you freed up to do things that matter for the business. That becomes a shame back against those teams. It's raining in Texas, if you can hear that. I don't know if you can hear the background. It's like thunderstorming, pounding here. So sorry if there's a little noise on my mic. All right. Well, I am available via Twitter if you have questions or via my email address, which I put in the chat. Happy to answer any individual questions at any time. Reach out if I can help you. I'd be happy to, and I'll be around for a little bit here.
Awesome. Thank you very much.